All right, this is Ubedo on behalf of V Electronics, and in this video, we're going to be learning about box whisker plot. Now, a box whisker plot looks something like this. Okay, you have your number line, for example. You have zero, negative values, positive values, for example. And your box whisker plot, this will have a whisker on the left-hand side, a box in the middle, okay, and a whisker on the right-hand side. You'll also have a dash line somewhere in the middle. Now, your dashed line is for your median. Okay, your whiskers on the left-hand side, this is for your minimum value. On the right-hand side, this is your max value. Okay, over here, this is your first quarter. Okay, this would be the starting point of the box, and the end point of the box, this is your third quarter. And your median would be your second quarter. All right, so say for example, if you were to have these values on a sheet of paper, let's say 25, okay, 30, 20, 15, 30, 25, and 20. Okay, we know right away that 15 is the median. Okay, we have a total of 7 values. Okay, this one is in the middle. This is your median or your second quartile. We also know that our first quartile will be 30 because our first quartile deals with the lower half of values. Okay, the lower half of this distribution of values. And this has to do with 30, which means our first quartile, the median for the lower half of the values listed over here, okay, this will be 30. And the median for the upper half of these values, okay, this will be 3 values. This would be your upper half. And the median for this upper half is 25. So this is your third quartile. Now that we have our first and third quartile as well as our median, it's now time to jot down our values on a box whisker plot. Okay, now apart from these 3 values, we'll also need our min and max. So over here, if you may notice, our minimum value is 15. Okay, so min is 15. And our maximum value, which repeats twice, is 30. So max equals 30. All right. Now, just to make things easier, if your min value was 5 and your max value was 50, it would be a whole lot easier to jot that down on a box whisker plot. Okay, so just for demonstration, we'll use 5 and 50 as our min and max. Okay, so say for example, okay, this is 5 over here. Somewhere over here you have 0, and somewhere over here you have 50. Okay, so your whiskers start at 5 and they will end at 50. And the box in the middle, okay, the line of the box, the starting point of the box will be your first quarter. So let's say first quarter over here. Okay, this is 30, 30. Okay, so we'll type in 30 over here. And your third quarter is 25. So this will be 25. And because this is a number line, just for demonstration, if this was 40, for example, okay, it would show up on the number line as 40 over here. Okay, so let's say this is 40. Okay, so 40, 30, 40, and then right in the middle, okay, this is your median or your second quartile, which is 15. All right, so this is basically how you would jot down your box whisker plot. Okay, now in an ideal world, this is something that you would see when it comes to your box whisker plot, but we don't live in an ideal world, as a result of which we do have values that are, uh, let's just say, out of the ordinary, as a result of which, okay, they may not fit perfectly on your number line. Okay, however, if you were to jot down your box whisker plot, okay, we know that our first quartile will be 30. So this value over here, this is 30. This one over here will be 25. And this one over here, this will be 15. Okay, we also know that our min was 15, and this would be 30, our max. Okay, so this is what the box whisker plot would look like, okay, if you had these values over here. Okay, these values, okay, show up on your box whisker plot. Now, some of the applications relevant to a box whisker plot include, but not limited to, finding out how far away, okay, your outlier is from the rest of the values. Okay, so say for example, in this case, if you had an outlier, your maximum was 200, okay, it would be really far away, right? Your whisker would look something like this on the right hand side. So 200 is far away from the rest of the box, okay, which shows you how far away your outlier is, your abnormality is from the rest of your values. Okay, so that would be one application when it comes to your box whisker plot. Now, apart from that application, you can also use your box whisker plot to compare data. Okay, you can use your box whisker plot to analyze process performance. Okay, to analyze your financial data. So to analyze, okay, your anomalies in your financial data, like stock returns. Okay, summarize data distribution. Okay, it's used for medical research as well as education. Okay, these are some practical applications of a box whisker plot. So that would be it for this video. On behalf of V Electronics, this is Obey. Have yourself a great